The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome guys. In this video, we're going to be solving this very problem. So let's get started. Please take note, there's no need for you to graph. Because if you actually graph this, that's a parabola. So you're not going to be making things easy for yourself. Also, even though s squared is even on its own, the interval is not symmetric. So you do not want to stress yourself about drawing so many things. Though the idea is very important that you have it to know whether it's even or odd. But in this case, we won't really be using it to simplify the formulas for our Fourier series coefficients. So you have to find your coefficients with the formula itself. So A0 is 1 over pi integral from 0 to 2 pi, because this is the interval, 0 to 2 pi, of f of x dx. That's our A0. So this will then become 1 over pi integral from 0 to 2 pi. Our f of x is s squared. So that's what we have. It's x squared. Now this is 1 over pi. Then if you integrate s squared, you're going to have s cubed all over 3, because you are always going to be saying 2 plus 1 over that same result. So that's the formula for integration. Then put your limits 0 to 2 pi. Now because this over 3 is a constant, so just bring it out. So this will be 1 over pi. If the 3 comes outside, you then be having 1 over 3 pi. The one will be left inside will just become s cubed from 0 to 2 pi. So this is 1 over 3 pi. Next, let us put in x as 2 pi. So this will be 2 pi cubed and then minus 0 cubed. So what I did was, the first time I put 2 pi, second time I put in 0. So that's what I did. Now this will be 1 over 3 pi. Then, if you should expand this, 2 cubed is 8. Then pi cubed remains pi cubed. This 0 cubed is nothing, so it's gone. So this will then become 1 over 3 pi times 8 pi cubed. So this can then be reduced as 4 pi squared over 3. The pi cubed can be divided by pi. Did I say 4? Sorry. That's 8. So the pi cubed can be divided by pi to give us pi squared. So this is A naught. That's A sub 0. So A sub n is 1 over pi integral from 0 to 2 pi of f of s cos nx dx. So this is A sub n equal 1 over pi. Now, integral from 0 to 2 pi, the f of x was s squared, that's our function, cos nx dx. Now this is 1 over pi. Now the short form of, should I say the faster way of integrating by parts, the faster way is for us to write s squared. So write s squared, differentiate s squared until you get 0. So this is s squared, differentiate s squared, you get 2x, differentiate 2x, you would have 2. Differentiate 2 is 0, but you don't want to write that 0. And this is cos nx. So what we're going to be doing with the cos is to integrate it. So integrate cos nx, we're going to have sine nx, then put over n. Because you must always divide by the derivative of nx. Now this sine nx over n, integrate it again here. Integrate it again here. What are we going to be having when you integrate it again? This sine, when you integrate sine, you have minus cos nx. Now, differentiate the angle nx, you will get n. But remember that there has been an over n before. So when the two n's meet, this will be n squared. So this is what we have. Then next, this value you have here, this whole bracket, integrate it again because there's another number here. So this is minus. Integrate cos, you would have sine. Then nx will be written down. But when you differentiate nx, you will get n. So n will meet this n squared to make this n cubed. So you see that, right? So this will then become plus minus plus. That's how you do these signs. So this is 0 to 2 pi. Now let's simplify this whole expression. So this is 1 over pi. Then we have s squared sine nx over n. Minus times minus is plus. So this is plus 2x cos nx over n squared. Plus times minus is minus. So this is minus 2 sine nx over n cubed from 0 to 2 pi. Now, the good thing about this whole thing, the good thing is sine is a very funny function. Sine of n pi is 0. Sine of 2n pi is 0. Sine of 0 is still 0. And our limit is 2 pi and 0. So it means this guy will give us 0. This guy would also give us 0. So the only useful one is this. The only useful one is this. So this will be 1 over pi. And then we're going to be having, this is 2. X is 2 pi. So this is x bracket 2 pi. Then cos n, s is 2 pi, right? So n times 2 pi is 2n pi. Then everything will be divided by n squared minus the lower limit. So this will be 2. S is what? 0. Cos 0 over n squared. Okay. Now this will be 1 over pi. 2 times 2 here will give me 4. So this will be 4 pi times cos 2n pi is 1. For cosine, cos 2n pi is equal to 0. Cos n pi is minus 1 to the power of n, but we're not using that in this case. Then cos, wait, did I say cos 2n pi is 0? Cos 2n pi is 1, then cos 0 is 1. So this cos 2n pi here, the value is 1, divided by n squared. And then minus, provided there's a 0 here, 2 times 0 is 0. Every other thing here will become 0. So just take that out. Every other thing there will just be 0. So pi will cancel out pi. What will be left here will become 4 over n squared. That's it. Let me put some of my answers here. So this is a naught. Then a sub n will become 4 over n squared. So now let's find b sub n. So b sub n is 1 over pi integral from 0 to 2 pi f of x sine nx dx. So that's b sub n. Then let us put in our function. So the function is s squared. So this is 1 over pi integral from 0 to 2 pi of s squared sine nx dx. Now what I'll do next is I'm going to use integration by parts. But there's a shorter way to do that. So this is 1 over pi, then open up a bracket. This s squared, you're going to write x squared. Now differentiate s squared until you get 0. So when you differentiate s squared, you will get 2x. Differentiate 2x, you will get 2. Differentiate 2, you will get 0. So you don't want to write that. Now the next thing you want to do is sine nx, you're going to integrate sine nx. So when you integrate sine nx, you're going to be getting minus cos nx over n, because you must always divide by the derivative of nx. It's a must. Now this bracket here, you're going to keep integrating it until you get to the last part. So let's integrate this whole bracket again. So to integrate this, there's a minus first, so you write minus. Cos, when you integrate cos, you will get sine. So this is sine nx divided by, now remember that when you differentiate nx, you will get n. That n will come and meet this n that has been here. So that will now be n squared. That will then be n squared. Okay, close this up. Now everything in this bracket, integrate it again. Integrate everything here again. So to integrate everything here again, there's a minus here, so you write your minus. When you integrate sine, you will get minus cosine. So that means there's another, let me say times, minus cosine nx, then divided by, when you differentiate the angle ns, you get n. That n will come and meet this n squared, so make it n cubed. Then you put your limit 0 to 2 pi. You must always divide by the derivative. That's how you integrate trigonometric functions. Then the sign will then become, this is plus, minus, plus. That's how the sign goes. Then you close this. All right, let's simplify this up. Let's simplify this up. So this is 1 over pi. Then we have plus times minus here will give us minus. So that's minus s squared cos nx divided by n. Minus times minus is plus 2 sine nx divided by n squared. Minus times minus is plus. Plus times plus again is plus. So this is 2 cos nx divided by n cubed. From 0 to 2 pi. Remember to hit the subscribe button if you have not done so. Like this video and leave a comment. All right. Now the next thing we're going to be doing is to impute our limit. But you know, sine is a very funny function. If we should put x as 2 pi, so you then have n times 2 pi will give us 2n pi. Sine 2n pi is 0. And if we should put 0 here, it's still 0. So this sine guy, this sine guy is gone. So this here is 0. So let's just pretend like it doesn't exist. So this is 1 over pi. Now let's start with this one. Let's start with this one. This will be minus. Let us put in our 2 pi here. So put in 2 pi, you're going to have 2 pi all squared. Cosine of, this is n. N times 2 pi will give us 2n pi. Then we'll have over n. So this is the first part when you put in the upper limit. Then you're supposed to say minus the lower limit. So you put in your lower limit here. This is x, right? So this x will give you 0. And 0 times cos 0 is 0. So everything will just be 0. So that's for this first part when you put in your limit. Next, let's come here and put in our limit. So this will be 2 cos. Put in your 2 pi here. This will be 2n pi divided by n cubed minus, let's put in 0. This will be 2 cos 0 divided by n cubed. That's beautiful. Yeah, that's beautiful. Even though this will disappear. Yeah, this will disappear. So you know why it's also going to disappear. So this is 1 over pi. Then this is minus 2 pi squared is 4 pi squared. Cos 2n pi is 1. That's a special value. Cos 2n pi is 1. So 1 times anything is that same thing. Divided by n. So that's for this part. The minus 0, just to take it away. Then plus, this is 2. Cos 2n pi again is 1. 1 times 2 is 2. So this is just 2 over n cubed. Minus, cos 0 is also 1. 1 times 2 is 2. Divided by n cubed. So that's what we have. So as you can see, 2 over n cubed minus 2 over n cubed is gone. So this guy is gone. So this was left. So this is 1 over pi. Then we have minus 4 pi squared over n. Now, this is pi squared. This is pi. They can cancel out. So this is minus 4 pi over n. Because this pi squared over pi is pi. So this becomes the value for b sub n. So let me write it here. B sub n is minus 4 pi divided by n. Now as you can see, even if on a normal day s squared is even, because of the interval, it is not going to be considered as that when we're dealing with Fourier series. If that function was just standing on its own, we won't be considering if it's even or odd, because it's going to be even. But when you look at that interval, so it guides you. So you don't just assume that, oh, s squared is even everywhere. No, your interval must be symmetric. Your interval must be symmetric. All right, so this is what we have. So that would be the answer to our problem. Let's find the Fourier series finally. So f of x is a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. So that's the formula for Fourier series. Now, let us put in our a naught. So f of x is equal, now a naught is 8 pi squared over 3. So that's 8 pi squared over 3. But don't forget that there's also an over 2. So they'll both times themselves. Because there has been an over 2 before, they will both multiply themselves. plus the sum from n equal to 1 to infinity. A sub n is 4 over n squared. That's 4 over n squared cos nx plus the sum from n equal to 1 to infinity. B sub n is minus 4 pi over n sine nx. All right, so let's simplify where we can. 2 here is 1, 2 into 8 is 4. So this would then be 4 pi squared all over 3. Now, the constant here is 4. So bring out 4. So this is plus 4, but the sum from n equal to 1 to infinity of what will be left here is 1. So this will have removed 4. 1 over n squared will be left, cos nx. Then the constant here is minus 4 pi. So you can bring it out, minus 4 pi. Then the sum from n equal to 1 to infinity of 1 over n sine nx. So if the equation says leave your answer in terms of n, this will be the answer. But let's try to kind of simplify a little bit. Let's write some terms inside. So f of s will then become 4 pi squared over 3 plus 4. Let's open up a bracket. So anywhere we see n, we're going to be putting 1, 2, 3, 4, 5, just like that. So let's put in 1 here. This will just be cos x, because 1 over 1 is still 1. Cos 1x is just cos x. Let's put in 2. This will be 1 over 2 squared cos 2x. Let's put in 3. 1 over 3 squared. This is n here. So this is 1 over 3 squared cos 3x. Anyway, you see n, that's where you're putting the number. Plus 1 over 4 squared cos 4x. And just like that. Because you can't really go to infinity. Then this other part. Minus 4 pi. Now, anywhere you see n, you put 1. So this is 1 over 1 sine 1x. So which is just sine x. Plus the next one will be 1 over 2 sine 2x. 1 over 3 sine 3x, just like that. So this will be the answer to the equation. Now, I believe Uniben exam, they've asked this question. But here's the problem. There was another part that says we should deduce a particular series. There's a mistake in that very problem. To deduce the series pi squared over 6, the exam was even set and they said you should say let x equal to 0. If you put x equal to 0 here, it's not going to work. To start with, there's a discontinuity at x because x cannot be 0. We're told that x is greater than 0. But let's leave that. Let us agree or assume that s is equal to 0. When you impute that into this very function, you won't be getting pi squared over 6. However, if the interval were to be minus pi less than x less than pi, then you can carefully get this. You can. But in this case, you can't. So many a times, because there's 1 here, 1 over 2 squared here, 1 over 3 squared here, 1 over 4 squared here, it doesn't mean that you can now get pi squared over 6 because it's there. Because pi squared over 6 is actually 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, just like that. So because it is here, does not mean that if you say let x be equal to 0, they are going to deduce that function. So that was what I noticed with this very problem. And yeah, I believe in the exam, Nigerian exam, just give them what they want. So if they say pi squared over 6, just write this thing for them. So that's it. In a much more better way, pi squared over 6 is equal to the sum from n equal to 1 to infinity of 1 over n squared. Still the same thing. So which was the 1 over n squared that we had before. So I guess that's just all for this very problem. I'll see you in the next one. Thanks for watching.